right, everyone. Welcome to an improved stats program for us, and it's better than anything else we got. It does everything automatically for you. You have a link to it. A few things to know. You might have to install some packages. So in order to do that, you can go all the way down to the bottom. And if you when I hit it, it ruins my whole thing, so I won't hit it. But if you hit this little green arrow right there, it should install all the packages you need for this project, okay? So if that doesn't work, just text me, call me, whatever, we'll figure it out. So that being said, there's another way. If you see a package, it says you need a package, you can install and you can search for the package here. Like if I want to install Tidyverse, which is actually a lot of packages, I can do that. I'm not going to do that because, like I said, I've already got this stuff installed, and it kind of acts quirky. When you do it again, it gives me some error messages and stuff. So let's see here. Where are we going to start? Number one, the first thing on here is a decision tree. It's fairly simple. You got to think like it's the 1980s. So this block will let you know which test you should run. So you should never, ever fail at this. I want you to ignore this section right here. All this is defining your answers. So if you type no or yet or n or small n or within or between, it all is read in. So with that said, you got to ask yourself, just in this little area right here, you got to fill out the data. How many samples do you have? Let's say I have 2. Now let's say I have 1. How many independent variables do I have? Well, if I only have 1, I can only have 1. If you mess that up, it will give you an error message. It says, I'll show it to you, actually. I'm going to go ahead and mess it up so you can see it. Do I know my population mean? Nope. Do I know my population standard deviation? Nope. Is it a within subject's design? It's a between. And what we know, this is impossible. It's impossible to have one sample with 2 independent variables, but let's see what Gandalf tells us. So then stuff runs and you get all scared. All you do is scroll down to the bottom of the little block. You don't have to worry about what's going on in here. This is what I've been working on for a while. And I really enjoyed working on it, so don't feel bad. But it says, Stats Gandalf says, you shall not pass, fix your answers. So then you go back and you're like, okay, I totally messed this up. So I have 1, and do I know my population mean? Yes, I do. Right? And then, do I know my standard deviation? Nope. This doesn't matter here for the 1 sample test. It's not perfect. I didn't have time to make it foolproof. So, but now you got, Gandalf says, run a 1 sample t-test, right? Like, that's pretty good function. You won't find that in any other stats program. That's because I like you all. Then you got, this is doing nothing. Then you can see, look at more 80s fonts just to make you all happy. You fill out your data here. So this is the 1 sample Z. So I need your data. I need your known population mean and your known standard deviation. These numbers are just for fun. Let's see what happens when I crank it. Oh yeah, that's right. We have to let it run and then we just move on down. And you can see I have an outlier output. So it says, you can has no outliers, silly cat, no outliers found. I like to have fun with the output messages sometimes. You can judge me. But ultimately, you get this one that pops up, tells you if you have any outliers. This one pops up and gives you all your statistics. Your sampled mean, your standard deviation, your sampled mean difference, your z-score, your p-value. I made this ridiculously ridiculous with a 94 Cohen's d. If you look at my numbers, I made it kind of nuts. You got your 95% CIs of everything over here. Your p-value is 0 in this case, right? It really helps you. All that stuff can help you understand everything. The main ones, though, are the sampled mean difference. Right, we know that the true mean difference lies between 94 and 93-ish, and the Cohen's d, of course. So the true effect size is large and large. Now I just made up that data, so don't freak about it. 1 sample Z test. We hit the run button. Put in your data. This one's pretty easy. Put in your data and your known population mean. Just put it in there. You run your data. and it runs faster. I'm just a little slower behind it, right? You go down to the bottom, you'll see these outputs, and you want to look at them both. Did you have any outliers? Outlier detected. Oh yeah, we had some outliers. You can see the original and the follow-up, just so you know. It does it automatically though. Then after that, you get your sample mean, your sample standard deviation, your sample mean difference, your t-value, your p-value, your Cohen's d, and your 95% CIs of all of these. This is a beta version. Some of these stats might be a little off. They're mostly correct, but I might have like a p-value calculator off. So if you notice something, don't be like, oh, that doesn't make sense. I'm just going to assume I'm wrong. Let me know, because it could be in the program. But like things that I'm looking for is, okay, my p-value here is greater than 0.05. So I want to see like confidence intervals that cross not of the sample mean and standard deviation, but I want to see confidence intervals of the mean difference that cross 0. I want to see a t that crosses 0. I want to see a p-value that goes to 1 because it crosses 0 and is 1. That one's a little harder to explain. And then Cohen's d that goes from negative to positive. So yes, this is good. Dependent samples t-test. Let's see what happens here. You know, you got to put in this one. This one, I'm going to go back and look up the other one for a second one. You got your condition, your data, your name, your condition, and your name. So you have names in there. I want to make sure I did that in the independent samples. But if oh, no, I'm not there yet. I put dependent samples first. So enter in your information. That is my cat, Rosie. She likes you all. She appreciates that I'm home, kind of. She's one of those kitties. But anyways, you just enter in your data with the dependent samples t-test. Remember, you have pairs of data. So if these, I don't even know if it'll kick you an error message, but you'll be doing the wrong test if you do not have all your pairs of data entered and you don't enter them in a way that makes sense. So you have these two scores are connected, these two scores are connected, these two scores are connected, and these two scores are connected. And so let me click the run button. It runs. We're going to get a very similar output to we saw before. You got no outliers there. Sometimes you got to read it. I'm kind of funny that way, but but at least I have no outliers, and I probably spelt that wrong. But then we get the same kind of thing. Look, it's putting my Fruity Pebbles mean and standard deviation here with my 95% confidence interval of the mean. I just did it of the means. Nobody does it of the standard deviations. Your Fruity Pebbles mean and standard deviation. There you go. And then the stuff I'm interested in, mean difference, t-value, p-value, Cohen's d. And I'm looking for that same thing. I have a very significant effect. 2 Cohen's d's on the same side. A p-value that does not cross 1. I'm just checking my coding here. You don't have to do this on your own. And a t-value that stays on the same sides because that's a significant effect. Let me go handle this cat real quick. Little bugger. Okay, I handled the cat. So now I'm back. And yeah, I'm going to leave that in the video because y'all are fun. So then we got our independent samples t-test. This is the same thing. We got 2 different groups. We can have unequal n. It doesn't matter here. You got condition names. You know, this one's testing out psychology majors versus worse majors. You enter your data, you click your button, you wait a couple seconds, you start pushing down, ignore all the code stuff. You know, if you see something from the console, don't worry about it. It's just an error message or it's telling me, oh, there's something weird here. That's a message for me when it's on the console. Here's my outlier detector. Outlier was detected in the first sample. You can see how the data gets reduced. And here it says, this one's a let it go reference because I'm that guy. And then again, we got our means and standard deviations. Same output as before. So you got your means, your standard deviations, your 95% confidence intervals of the means because, you know, what I haven't calculated the 95% confidence interval of the confidence interval yet has requested, but someday soon. And then the stuff I care about, the mean difference, my t-value, my p, and my Cohen's d. And then I'm just checking everything's looking good. So that look at how easy this is. You enter your data one way between subjects and ANOVA. Enter in your data, enter in your conditions. right? This is the between subjects ANOVA. That's all you got to do. Enter in your condition labels, enter in your data, click Mr. Run button. Let it run. These bottom ones take a little bit longer. You had me diving into stuff that I haven't dived into, that I had to learn. So this output is really cool. Remember, the console's for me. This is the outliers. This one isn't as fancy. It just throws an NA up if there's an outlier. So we can see that we had one Luigi, one Bowser outlier, and one Peach outlier. Of course, Super Mario Brothers. I'm a nerd. Then look at this beautiful table. I love it. This is an ANOVA table that's doing so much more than you could ever think of. So it has all your sources, between, within, and total. It has the sort of conceptual foundation of that total. So you got signal and noise. You've got all your sum of squares, and it does this beautiful thing where it gives you the proportion of different how different things are related. So you can see there's almost no error compared to the treatment effect. You can see that the treatment effect is almost the whole variation in the data. Based on that, this partial eta squared is literally just this fraction right here. This divided by this guy equals 0.87. That is it. But you can see it right here. A large majority of the variation in our data set, the total, is driven by our independent variable of whatever the heck I made up there for you all. Isn't that beautiful? Degrees of freedom, sum squares divided by degrees of freedom. My F ratio, 95% confidence interval of the F. My P value, 95% confidence interval of my P. And yeah, this one's a massive effect, so I'm not too worried about it. Yeah, these are massive effects for sure. My F was, yeah, those are huge. I was just making sure my programming was okay. My partial eta squared, my 90 CI of the partial eta squared. It's okay that I didn't mark that or you don't remember that. Just call it the confidence interval. It's a 90. I'll fix it later, but not right now. This is beta, and that is a beautiful graph. Then we got our means and standard deviations and conditions graph. This is an ugly graph, but I don't really care about it. This isn't the main place that we spend our attention. It's on our omnibus test, and then it automatically gives you this one because it is the between groups. It gives you the HSD. Just note these are Q stats, but other than that, you got your Q stat, your 95% confidence interval of the Q stat, and you can see that some of them go to infinity. That means they're infinitely large. And it's just due to the shape. When you look at the confidence intervals on some of these things, they look a little weird because the distributions are weird, particularly the F and this Q. But you got your mean difference, your 95% confidence interval of your mean difference, your P's, your 95% confidence intervals of your P's, your Cohen's D's for each one, and your 95% confidence intervals for the Cohen's D's, right? This is everything I've ever asked for and some stuff that I've only talked about, but the p-value stuff is cool. Ultimately, though, it's all right here. All these complicated stats are done in a moment's time, and it's beautiful, and it's going to save us so much time. If you want, you can look at how I programmed it. If you're really that interested, I'd rather you come talk to me about it or call me now in the pandemic, experience. But, I think that's really fun. And we get to our one-way ANOVA. All right, so now where were we? We are on that final test, that one-way within ANOVA. And so all we do is we put in our data and we hit the button. Now, what do you need? Well, you need the same person needs to be in all conditions. Otherwise, it won't work. Don't add their data if they're not in all conditions. Yeah. So that's my advice for that. Or you're going to have to talk to me and we can calculate it a different way. But ultimately, that's the thing that matters. Then you type in your condition names here, right? You type in your data here, and you type in a subject ID. It can be a number or a letter. It doesn't really matter for this one. But we do that. Everything works out. We get all our data in. We click the button. And now we're going to wait for it to finish. Look over there on the right. We're going to go on down. And I know it's pretty far. I wrote a lot. You can see I wrote a lot of code. I wrote 1,500 lines of code for this. And that's where I've been. Like, people have been like, where you been at? I've been like, I've been doing this. First thing you get is, you can't really tell because I had them put everything in here, but it tells you if you had any outliers, and you can see you had one right here. After that outlier, you don't have to do anything. The program removes all that person's data from the entire thing. So participant 4 is removed from our data set. This is stuff for me, like I said before. This is probably my masterpiece. I am so in love with this graph, you don't even understand. So first thing, it's an ANOVA source graph, but it's for the within subjects ANOVA, which has more sources, which is just so cool to me. And so what you can see here is I have them conceptually defined. Signal and noise, noise, crap, signal plus noise plus crap. That's everything. Noise and crap is within, right? So now you can see a lot of people are like, what's subjects? What's this? Well, look at this graph. Like, within is noise and crap. It's error and subjects, right? Crap doesn't affect our F ratio. The F ratio is basically the signal to noise ratio. And you can see here, -1, as we talked about earlier. But look at this. This F ratio is 13. This bar is 13.402 times the size of this bar right here. The total, if it was wider, all these would, actually I think they do. They all add up to the total of the 308.80. So you can see, like, oh, this is the total variation in our data set. Some of that's due to crap, that's right here. Some of it's due to error, and some of it's due to our manipulation. There's also noise plus crap, but notice that that's already been accounted for before. I'm just showing you that within is noise plus crap. Your degrees of freedom, which we know how to calculate. Your variance, which is just basically put a big division sign here. You get that number. Your F ratio, your p-value, your partial eta squared. Now, partial eta squared, you can see on this specific map. It's easier to see for the one-way between ANOVA, but basically if you take this plus this, divide this, okay, it's not that easy to see, I'll admit it. But basically the idea is that you do the same thing as before, your sum squares between divided by your sum squares total, except now you take crap out of the total. So it's you got to take this little guy out of that total and say, okay, of the total variation, a vast majority is driven by our effect. And particularly 87% of the variation in our DV is caused by our IV. And look, this is about 87% the size of this minus subject. So you got to take that a little bit off. So, but still, it's showing you all the proportions. This stuff isn't all made up. It's pretty fun. Variance, we already talked about your F ratios, your p-values, your partial eta squared, 95% confidence intervals. And then you get, this is your means for your means table. You're going to need that, like means and standard deviations. But I didn't really spend time on that graph. But here you go. Here's all your LSD comparisons, your mean differences, your 95% confidence interval of those differences, your standard error, which I should have taken out, but I didn't, your degrees of freedom, your T value, your 95% confidence interval of the T, your Cohen's D, your 95% confidence interval of D, your P, and your 95% confidence interval of P. And everything looks like it's working out to me. So, yep, perfect. What a fun little project this was for me. I really appreciate that. Now, if you have any errors, just take a picture, screenshot it, text me, and I can figure it out. Generally this is hosted on just like a web browser. The one thing I don't like about it, it doesn't auto load my packages. So when you log in, you got to log in. I've shown you this before. When you click the link, it'll ask you for like a Gmail or a Facebook login. Just log in. And then, try to run it. And if it gives you any errors, like you can install packages, there's 2 ways to do it. You can click my little arrow button here, which I know I mentioned this before, but I want to mention it again. And this should install it. It might fail. I can't do it because it gives me all these error messages because I already have the packages installed. Another way to do it is just to literally search for each package individually. Tidyverse. Boom. I have put calls in my code at the top of my code to all the libraries I'm using. So, and I think I gotta get to the top of the code. So I have this on most. I don't use it. I really only use it on the last couple, but that all those libraries I have there. So if you hit an error, it'll say, oh, this isn't installed, so it won't really freak you out. But if you have any problems, let me know. But look at how quickly we just did stats. This is beautiful and for me as a teacher. So I'm really excited. I hope y'all are doing well. I miss you. I'm still not going to do the whole Zoom thing. I might with you all if you want to. But yeah, I'm going to figure that out. I'm going to hold some just open virtual Zoom office hours. I just rather do stuff on YouTube, honestly. But yeah, I'll check it out. I'm still not going to hold class even though they give me a thing. I want you to spend your time with your family. I want you to spend your time getting healthy. I want you to spend your time getting safe. And so, this is part of that. To me, you saw how long it took me to do that PSPP thing. Well, I spent 2 weeks, literally, 2 weeks programming this in for you. Not every day. I also I guess it's been 1 week. I ran a study. I collected 300 participants or 280 participants and got that done. I haven't analyzed it yet because there's a lot of just stuff going on, in the world right now. But I'm going to analyze it soon and I'll report back, let you know what I found because I love science. And so yeah, and then look at these graphs, right? You're like, oh, what do I do? What do I do here? It's like the decision tree, the one sample Z. Sometimes you get stuck on a low guy. You got to keep, see, it's just like computers get stuck. One sample T, dependent samples T, independent samples T. And yes, there's just a place you can go to make these. One way between subjects ANOVA. And you're one way within ANOVA. And y'all saw that. Outlier detection. Regular test. An omnibus test. Post hocs. Everything all done at once. Everything all done at once. Everything all done at once. You'll have this link soon.